Hello, this is Physics 2211, Lab 5 by me, and let's begin. So, introduction, purpose, see if energy is conserved in a Ghana trampoline. Models used are GlowScript, principles used are conservation of energy, Newton's second law, and springs. A preview of the results, here you can see the model. Physics ideas used are conservation of energy, Newton's second law, and springs. System and surroundings, initial conditions. You can see on the picture the setup. System is the guy, the wall, the trampoline. Surroundings, air. Initial conditions, wall is at x coordinates, you can see that. A guy at these coordinates, velocity, as you can see there. Trampoline at coordinates, you can see there. So, tracker. Here's how I tracked the guy. GlowScript. Here's the code snippets. At the left is the initial conditions setup. At the right, the calculation time loop. Yeah, I modeled the guy as a ball, the trampoline as a spring that gets stretched only when the guy is folded onto it, and wall as a reversing thing. Yeah. So similarities and differences. Here you can see the graphs of position versus time, and you can see that the the amplitudes are similar, but the intervals are not similar. That's probably human error and the model error. So yeah, sources of error are bad angle of view, difficult to track the guy because it's complex shape, it has and he moves in the air, so his center of mass over constantly shifts. Unknown weight of the guy and stiffness of the trampoline, and human error. So what if there was no wall? The guy would fly away on the x-axis and reach the ground, which moves up his energy. What does it mean? Energy is conserved. Here you see the graph of energy. You can see there's some weird stuff going on when the guy hits the trampoline, but mostly the energy is conserved because delta E is mostly the same. Like, average of it is the same. So the energy is conserved. That's it. Thank you for your attention. Yeah, bye.